Hello everyone. So thank you very much for receiving me today. So today I will introduce you Bon Vivant. I will introduce what we are doing, what is the technology of precision fermentation that has been introduced earlier, what is the positive impact of our technology, but also what are the challenges that we are facing currently, and what will be the opportunities for all of us to make this technology to be happen in our plates. But before I introduce the company, I would like to introduce myself. So I'm the co-founder and the CTO of Bon Vivant. My background is zootechny, so I was an animal nutritionist and specialized in dairy cow nutrition, mostly in Asia. Then I shifted my career into insect farming, mostly working for Onto Food in black soldier fly. And I had the opportunity to go back to France after Asia to create Bon Vivant. It's not because I'm thinking that there is no future for dairy production. I'm very far from that. I think it's there is still a lot of improvement, and improvement has been done a lot since many years, and I recognize that. However, I really believe in the complementary solutions to be produced to provide different sources of proteins to the consumers. So what we are believing in, and what I believe in as well, we are facing couple of challenges that we all know about global warming, a milk production decrease. You may be surprised about the figures here, about minus 20% of cow milk production expected in Europe. So today the figures that are given are per year is minus 0.2% every year. However, these figures are directly coming from dairy producers, so from industrials that are expecting much lower decrease the next 5 years. In terms of population increase, we all know that the protein consumption will double in the next 30 years. And there is a direct shift in food diet. We can see more vegans, flexitarians that are increasing. But among the generation, we can observe 10% of flexitarians that are willing to try new food and try other type of diets. What is precision fermentation? So as explained previously, we have different types of fermentation. Fermentation, we can have traditional one that is used to produce alcohol since many times. And we have the biomass fermentation. And there is a new word, indeed, called precision fermentation. But this is not new, actually. Precision fermentation is using microorganisms that has been genetically modified to produce a very specific ingredients. And in the late 80s, we have been able to produce insulin for a pharmaceutical company, thanks to that technology. Then we have been able to produce some enzymes, specific enzymes for our diet. And there is one that we all know, is the rennet, the one that is used in most of the cheese to avoid you use the chymosin, so the enzyme to produce cheese. Now it can be synthetically produced, thanks to precision fermentation. And more recently, we are using that technology to produce proteins that we can find in our food, like casein and whey proteins. This is where Bon Vivant is focusing on. But how that technology has been affordable for food? Before, it was only possible to produce medicines because it was really expensive. We had the opportunity to know more about the microorganism, to discover more microorganism, to be able to picture the whole genome sequence of the microorganism. And thanks to some disruptive technologies such as CRISPR-Cas9 and other technologies, we have been able to produce ingredients for cosmetics, other feed materials, but also for food. So we are expecting in the 2030 that the price of milk proteins produced by microorganisms can decrease below $10 a kg. So it means that we could be at par with the actual whey protein isolates, for example. So how that technology is working precisely? So it is 4 steps. The first steps consist in metabolic engineering. So we are selecting very specific microorganisms, such as fungi, bacteria, and we can use yeast as well. And we are selecting in parallel the DNA sequence that are encoding for one specific proteins. And here we combine both. We insert the DNA of the specific proteins that we want to produce, and we grow that microorganism into a bioreactors. So today bioreactors are in the picture here for lab scale, so it's 20 liters, but today it is existing some bioreactors up to 200, 500 cubic meters to produce specific proteins or even enzymes. We cultivate that microorganism into sugars. Type of sugars are glucose, maltose, maltodextrin, so more or less refined. And the goal to become scalable and affordable is to use some less refined and industrial byproduct sugars. And then it comes to the critical step, which called the purification. So the idea is clearly to separate the biomass, so the yeast or the fungi that has been engineered, from the protein that has been produced by that specific microorganism. And here we are able to purify only the protein of interest in order to remove the GMO, of course, and also to provide high purity of the ingredients. The advantage of that technology is that we are producing high pure specific ingredients like whey proteins or caseins, and we can have the identity of that proteins, which is identical to animal proteins. So in terms of regulatory, it's non-GMO, so it's part of the novel food, but category 2 with non-GMO. Recently, we had the opportunity to perform an LCA on our process because we have been able to perform our process at industrial scale. And thanks to that, we have been able to compare what is the impact of our technology compared to cow's milk. The idea is not to criticize the cow milk here. It's really to be able to show that new technology can come on top of the actual agriculture and can contribute to a reduction of global emission. We have performed that LCA compared to European Eco-Invent data. So we have built a database with our protein that can constitute a full milk based on fat plant-based, for example, plant-based carbohydrate, and our protein considered as a main content of protein of the milk. And we compared with 1 liter of milk data. And we analyzed the 15 major environmental impacts, and most of the environmental criteria has been very interesting in terms of outcome. We have realized that gas emission related to the climate change can decrease by 96%, and other parameters such as acidification, eutrophication, but obviously land use can be reduced. But now, how we can use our proteins, because we are producing only pure protein of whey and caseins. So it can be really nutritive. As you know, whey protein is very rich in essential amino acids. So it can be easier used to enrich current dairy products. So we can put whey protein on top of the yogurt, on top of milk, in order to decrease the CO2 emission or the carbon footprint of the product. Or it can be mixed with plant-based in order to enhance the texture, the nutrition, and the sensory effect of the product. This is a big discussion that we have currently with the dairy industrials, because we are B2B, so we are providing only to the industrials. However, we are not ready yet to commercialize, but we are near to. The scalability process is a huge opportunity, but also a huge challenge, because our microorganisms are able to produce with high yield the specific proteins. However, we need to make sure that we are able to produce a large quantity in order to have that impact. It's not only to show that nice figures about my LCA, but it's also to show that we can have an impact, meaning that we need to produce more than 20, 30, 50,000 tons per year. So it becomes a huge challenge in terms of availability of bioreactors available. We are really lucky in Europe to have large amount of bioreactors companies. However, in US, for example, or in Middle East, there is very few bioreactors already installed. So huge capex investment needs to be done. That is why we have private investors, but also the French government with the BPI that could support us to invest in such capex. The cost reduction. This technology, to be acceptable by the consumer and by industrials, it needs to be at par with dairy product. Otherwise, they will not accept it. The key is clearly the strain productivity, so the microorganism, how much of gram per liter we can produce of proteins and from which carbon source. If we are using like very refined sugar, it will be difficult because we will compete with the actual agriculture sugar source. So we need to find a way to use some byproduct sugars or something more variable and make sure that our strain is robust enough to scale and to produce large amount of protein with a minimum amount of sugar. Interesting to see that the price has already decreased. We have already some companies that are commercializing animal-free dairy proteins in the US since 2 years, and you have already some agendas like Brave Robot ice cream available in the supermarket. It's still premium, I agree. However, this aiming at going into other dairy products to become more, to have more adoption from the consumer. Another challenge that we need to overcome is the consumer adoption. I'm talking about GMO. I have no fear to talk about GMO. I think we must use that word and not avoid it. We should bring transparency to the consumer and explain what is GMO and what is GMM. It's a genetically modified microorganism that is used as a tool to produce the protein, but the protein itself is without any GMO. And we need to show and demonstrate to regulators as well that is safe. And it is our role as Bon Vivant, as other startups, to submit under a transparency contract with EFSA preliminary data and not waiting the last step to submit the dossier. So currently, Bon Vivant is providing to EFSA some preliminary trial R&D work for them to really get used to have such a trial result and to adapt their regulation. And we have seen since 2 years an evolution of EFSA. For example, the notification. Before we had to notify EFSA every time for anything that we will do. Now it's getting more flexible. So we see an improvement on that. And then, again, to come back on consumer, we are already consuming precision fermentation or even fermented food. Rennet is one example, but insuline has saved a lot of people as well. And we really need to explain that GMO is not only for the derive of the industry, but also for the benefits of the consumer. Thank you very much.